what are we doing here? U of 1 is this computation. Okay, all right. And U2 is equal to this computation. Okay, let's work these out. As a matter of fact, I'm pretty much really tempted to just use Mathematica and do the computation. Okay, let's work these out. They're kind of similar. I'm going to do only one of them. Okay, how to handle this? Let's take the substitution. T squared is inside, so let's do this. Theta is t squared. d theta is therefore 2t dt, and therefore dt is 1 over 2t d theta. Okay, and then we're going to plug those into this. As a matter of fact, you can do the same substitution here as well. So U2 is this integral, and then instead of dt, I'm substituting this one in. Excuse me. Let me take an extra step. And then 1 over 2t d theta go here. And then what is t squared? That's theta. And then how about this t cubed versus this 2t? They cancel out. T squared, and this one half, and that 2 cancel out. And one more thing. What is t squared? That's theta. So we ended up with this computation. So substitution worked out, and then we have much simpler integral. How do you do this integral? This is going to be integration by parts. So this one is basically integral of u dv is equal to u v minus integral of v du. And then here, u is theta, du is d theta, and then dv v is cosine of theta d theta. Okay. So what is v? V is, let's see, v is sine. Let's see, if you take the derivative of sine, we get cosine. Okay, that's fine. So put this one into the integration by part formula. This is u dv, isn't it? U dv. So uv. So u theta times sine of theta. So theta times sine of theta minus integral of v du. V sine of theta and du. Okay, we're almost there. minus, what's the antiderivative of sine? Negative cosine, so we get that. One more step is necessary, I guess, because theta is t squared, so this is t squared sine of t squared plus cosine of t squared, and that is my u2. Would you like to check? Let's see, let's check. T squared sine of t squared plus cosine of t squared, and take the derivative by t, and then am I actually going to get this 2t cubed cosine of t squared? Yes, indeed, we got it. So this is correct antiderivative, corrects u2. And likewise, if you find out u1, t squared cosine of t squared minus sine of t squared, that's going to be u1. u1 is going to be t squared cosine of t squared minus sine of t squared. u2 is, as we did over here, t squared sine of t squared plus cosine of t squared. So we have those u1 and u2. Let's copy this so that I can go over to the next step. And then let's go to step 4. We got u1 and u2. So we get YH is u1 y1 plus u2 y2. And what is u1? This is u1. And then y1 is this one. And then what is u2? This is u2. And then here is y2. Let's put some spaces in between so that I can read a little bit more easily. Okay, so there goes a particular solution. Let's see. Maybe some simplification is in order. T squared cosine squared sine squared cosine squared cosine squared sine squared, that's going to cancel each other out. And t squared sine squared, we'll have a lot of cancellations. So we're going to get YH of P, YP, excuse me, not YH. Yeah, this should be Y particular solution, YP. Will turn out to be, let's see, t squared cosine squared cosine squared, t squared cosine squared, t squared, and then minus sine t squared cosine of t squared plus t squared sine squared t squared, all right, and plus cosine of t squared times sine of t squared. And do we have further simplification? Yes, this one and that one cancel each other out, and we get t squared times cosine squared plus sine squared t squared. Okay, what is sine squared plus cosine squared? That's equal to 1, so that's equal to t squared. Oh my goodness, I got something amazingly simple. So this is a particular solution. So the general solution must look like this. Therefore, general solution must look like C1 cosine of t squared plus C2 sine of t squared plus t squared, the particular solution. Homogeneous, another homogeneous, and particular. Well, shall we check? Let's clear some variable, and y of t is defined as, let's clear parameters constant as well, a cosine of t squared plus b sine of t squared plus t squared, okay? And then let's put everything into the left-hand side of this original differential equation. T times, oh, what did I click? Let's do it again. T times y double prime of t minus y prime of t plus 4t cubed. Let's see, let's simplify. Am I gonna get 4t to the 5th power? Oh, I didn't get it. Excuse me. What's wrong with this computation? 4to cubic power. See, I miswrote that one. Okay, sweet. 4t to the 5th power. This confirms all the computation I did is correct. One more checking. Resolve t times y double prime of t minus y prime of t plus 4t cubed y of t is equal to 4t to the 5th power, and then find out the function with this variable. And oh, excuse me, I have to clear the variable, otherwise I cannot solve the equation. Okay, what does it say? C1 cosine of t squared cosine t squared, C2. Okay, here t squared cosine squared, t squared sine squared. Cosine squared sine squared is adding up to 1, so we have actually this part and that part adding up to t squared. So yes, it matches with our solution here. You see, this part and that part is the same as this one. So yes, everything fits. So I'll say this problem is finally complete, and there goes a good application of the variation of parameter. You know what? Variation of parameter is almost useless in usual exam preparation, but for take-home exam, it's great. It's long, I know, but it's important topic, and it cannot be done in the usual exams. So if we do some take-home exam, variation of parameter is something you should really consider.